Okay, welcome to lesson 3 of unit 4, permutations involving identical objects. So lesson 2 focused on like when we were looking at rearranging quote-unquote words where each letter was different. So this first example 1, how many ways can the letters in the word Ella be arranged? It's a little different because although we want to put 4 lines, we only actually have 3 choices because we can't differentiate which L is which. Like, we don't label them L1 and L2. They're just L when we rearrange them. So there's only 3 choices. So we would originally, if we didn't have repeating numbers, write 4, 3, 2, 1. But we need to account for that repeating piece. So using our fundamental counting principle, we would have 3, and depending on if L lands there, we could have 3, 2, 1, or like 3, 2, 1, 3. Like, we've got too many options to choose from. So we can't really use the fundamental counting principle on its own anymore, is basically what we're getting at. So instead, we have to use the idea of permutations. And so remember that we would use that factorial notation of how many objects there are. So we have 4 objects. To pick from. So 4 is my initial, so I'm still going to work with that. But I have L, and there are 2 repeaters of it. So I would divide by 2 factorial. So again, that would be where we've got 4 times 3 times 2 factorial over 2 factorial, which would be 12. Okay, so when we have identical objects, we need to divide by the factorial of those number of objects. So example 2 here, we see there are 7 boxes of cereal on the shelf. 5 boxes are bran, and 1 is puffed wheat, and the other is granola. So in total, we've got 7 boxes of cereal. So that's still my initial starting point. So n equals 7. But 5 of them are bran. 1 is puff wheat, and the other is a box of granola. Okay, so the puff wheat and the granola are individuals, so they don't count as repeaters. So in general, I would say 7 factorial divided by 5 factorial equals 7 times 6, or 42 options. Because again, if they're all exactly the same box of bran cereal and none of these boxes of cereal are open, then they are exactly equivalent. So I can't count all those different repetitions. Example 3. Graham walks 8 blocks from his home to the library. He walks 4 blocks east and 4 blocks south. How many ways can Graham walk to the library? So in general, or we could draw a picture for this one. We've got 4 blocks east, 1, 2, 3, 4, and 4 blocks south. How many ways could he get there? Well, that kind of looks like, well, we could go this way all the way, and we could go this way all the way. So in total, we have to make 8 decisions. But we've got some repeating options. So we've got 4 factorial for going south, and 4 factorial for going east. Because it could be this one, this one, this one, this one, or this one. But that's all still within the first block. of going south, so it doesn't really matter. Okay, and then same thing with going east. It's 1, 2, 3, 4 options. And so here we would go 8, 7, 6, 5 over 4 factorial. Again, I've canceled out one of the 4s without writing it, which would be so I could take the 3 and the 2 out with the 6. I could take the 4 out and simplify that to 2. So, and that becomes a manageable number. So still I could have done this on my non-calculator part of my exam, because 7 times 5 is 35 times 2 is 70. A kebab recipe requires 2 mushrooms, 2 shrimp, 2 cherry tomatoes, and 2 zucchini slices. How many ways can Amelie arrange these items on the skewer? So in general, we've got 2, 4, 6, 8 options, but we've got mushrooms, which repeat twice, shrimp, cherry tomatoes, and zucchini slices are all repeating. And so we're going to have denominator pieces that account for mushrooms, shrimp, cherry tomatoes, and zucchini. In this particular case, I might want to actually use my calculator, but it should still be manageable from a standpoint of mental math. So 2 factorial, 2 factorial, 2 factorial. Now 2 factorial is just 2 times 1, so it's just 2, which means I can look at things like taking those out, but also taking those out. So I've got 7, 6, 5, 4, 3 that I need to multiply. So this would probably be more likely a calculator question, just strictly because of the value and the magnitude that we're multiplying. So we get 2,520 options. So hypothetically, Amelie could arrange that many different skewers. So if she's hosting a party where she needs over 2,000 skewers, each one could still be unique. Example 5, how many arrangements are used, or are there using the letters in the word Mississippi? This is a super common example. So we look and we say, okay, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 actual letters. But there are 4 I's. There are 4 S's. And there are 2 P's. And so that's where we get those denominator pieces from each of the repeaters. Based on this, again, I would expect this to be a calculator question, so you can give it a shot, make sure you know how to type that in. You get 34,650 different options. So quite a number of options. It would be even bigger if we didn't take out all those repeaters, because again, we can't tell the difference between one I and another I, so we don't know which one is being chosen. How many arrangements are there? This is example 6, using the digits listed below. So again, to start with, you just count the total number. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. But on the denominator, we do numbers of each repeater. So that would be for the 1s, there's 2 of them. For the 2s, there's 3 of them. There's only one 3, so that can stand. 4s, there's 2. And 5s, there are 5. Again, I would anticipate that this would be a question that you would see in the calculator section. But we will do it on our calculator. So if you're typing it into your calculator, make sure you put brackets around your denominator so that you are able to ensure that everything that's in the denominator or doing the dividing actually is doing just that. 2 factorial, oops, restart. You can see how I have to type it on the calculator here. And so then that should be my solution, 2,162,160. Okay, so again, there are 2 homework worksheets that go along with kind of these first 3 lessons. So definitely take some time, do some practice before you move on to lesson 4 tomorrow.